Welcome back. It's interesting how I mentioned we would be doing a hands-on coding activity, and then like half the class did not show up. Very interesting. Uh, this is, I think, in my experience, the most valuable part of the class is when you actually do something yourselves for the first time often. It's a good learning experience. Let's pick up where we left off. I'd like to, so if you remember, we talked about these Likert scales. Yes, so we talked about survey design and Likert scales. Okay. And we talked about this idea of a scale that's better than individual items. Does anybody remember this? What was the logic? So, anybody remember the logic? Long discussion about why use scales at all over just ask individual questions? I should really like do a quiz or something.
I'm trying to, but I can't even get past if I should try to remember the last class or if I should just try to think about it logically now.
So maybe let's start over. You remember what a scale was, right? Did I give you an example? Did I give an example of a scale, maybe? Yeah, I did give an example of a scale. So something like this, where you ask different versions of the same question, roughly. How is this so confusing? We just talked about
That's
this.
what you mean by scale. I wasn't sure if I assume by scale you mean what's the point of having like points from strongly disagree to strongly agree.
But we defined it. We called it the Likert scale, the whole
Yes,
thing.
I know that. I just wasn't sure you're like comparing like different questions, like multiple questions about the same thing.
Yes, the collection of questions about the
Yeah,
same
that
thing.
is different. I was assuming why we ask things on like a scale. That was what I initially thought.
Oh, good. We're back on the same page.
Yeah.
This is write only, right? Or like write only. There's no reading. Like it's sort of one-way communication here. Interesting. We're back though, right? Yes.
Yeah.
We remember this? Why did we argue that scales are useful?
Sort of, yeah.
Well, now everybody all at once.
Yeah. And I still have to catch up. I'm still catching up on.
Okay, we'll sit you aside for now. Andy?
It showed consistency, like over time, so if all like the positive worded ones are the same over time, that's probably more reliable and consistent with each other compared to all the ones that are negative can change.
Okay, super good. So yeah, that's part of it.
We also want to have like different dimensions of the same thing with different questions about the same thing to ensure consistency, like you said.
Yes, so both of these are true, right? You talked about stability, which is the second thing there, which is sort of over time, do you get sort of reliable answers to the same questions? And I guess you talked about consistency, meaning, if you ask about the same concept in slightly different ways or about different dimensions of the same phenomenon, you should get consistent answers, ideally. Otherwise, you're probably, asking the wrong question or something, or you're asking about a different concept. Okay, remember this? So scales are the golden standard for survey design, as opposed to asking individual questions. So like, actually, if you look at, um, you know, I don't know, your favorite phenomena or construct or whatever, I don't know, burnout or what's the usability thing? There's a famous one for like computer usability. I don't know, there's standardized instruments that people have very carefully designed and validated And you should always use one of these, reuse one of these, right? If you're asking survey questions about the same construct, you should never invent new questions if there's an existing validated scale that captures that. Okay. Okay, so with this in mind, let's do a quick one. Let's design a Likert scale to measure how much scientists integrate Gen AI into their research workflows. So you can choose 5-point items from strongly disagree to strongly agree. All of the questions can have this format. Come up with some questions. I don't know, 5 to 10 questions, something like this. Come up with some questions that measure different dimensions of scientists integrating Gen AI tools into their research workflows. Like imagine you were running a survey about this, right? So this means, like some statements that you'd be making that people have to agree or disagree with. So we're basically asking about this thing in various ways. I don't know, let's say at least 5 different ways. 5 minutes or less. Oh, and try to do this part by hand before we can. I mean, you can obviously ask an LLM to generate this for you, but just use your own creativity for a minute. Wait, my screen is not shared. That is terrible. There. Any feedback on this last question? There's maybe some ways we can improve on this.
I feel like it could be 2 different questions.
Yeah, remember the advice from earlier? Never ask 2 questions at the same time. In research questions, in interviews, in surveys. So this is many questions in one, right? Because do I strongly agree with the first part of this, with the middle part, with the last part? Do I disagree with some parts and agree with others? Like, so it's very hard to answer this. So maybe not this one.
Yeah, I actually wrote the, interestingly, I wrote the last part that I want to learn Gen AI as a new skill, but then I'm like, this feels incomplete. And then I added a revision.
Yep.
I think it's domain specific, like I trust Gen AI to write my software,
Yeah. To what?
right?
Yep. Andy.
On a research task, I am willing to use Gen AI to help solve my problem.
I am willing.
Yeah, I'm willing to use Gen AI.
I use Gen AI for qualitative coding.
Okay, so I think you get the vibe, you get the gist. each of you, right? So if you're actually doing something like this, if you're designing a survey, you want a number of these, like probably many, right? I don't know what the right number, I don't know if there is a right number. I mean, obviously, the more items you have in the scale, the more reliable the scale can be. We can talk about this in a minute. But also the harder the survey is to respond to. So like, if you show people 100 questions, they will throw the survey away without answering it. So it's kind of, you have to strike the right balance here for, um, sort of, increase in reliability versus increase in effort to respond to the survey. I think at least some, I don't know, 7 is the magic number, maybe something like this. At least some such number, 5 to 10 questions, all about the same thing. Okay. The other thing that's interesting here is that so many of these are positive coded, meaning, I'm satisfied, whatever, it helps me find valuable research papers, etc. But there's a couple that are reverse coded. I think, but depending on what your view is here, but I could interpret this one as okay, right. So this could be reverse coded, right? I refuse to use Gen AI even when it's helpful. So you would presumably want people to disagree with this. Same for this one. Was there another one?
I am scared to rely on Gemini.
Where is that one?
Fourth one.
Yeah. I mean, I guess this is, it could actually be the case, right? But, for other things you could have, and you've seen in the example I had here on the slides, I love writing versus I hate writing, for example, right? So like literal reverse versions of the same questions. Okay. All right, good. So, you do a number of these, right? And then have a scale, right, as part of a questionnaire. Maybe there's other things in the questionnaire. This is the one scale about, I don't know, Gen AI use in scientific research. And then you run this, right? And then you get, I don't know, a few hundred responses back, something like that. And you get scores on all of these items on your scale, right? So now the question is, how reliable is the scale that you've designed, right? You don't actually know how good these questions, the items were that you put on the scale, right? So let's do that next. Let's look at that. So here's a data set. I put it in the Slack channel. It has, I don't know, a couple of hundred responses or something. To essentially this survey, I have a scale with 7 items here. This is the scale I have responses for. Okay. So, very similar to what you had. Right? The data set is simulated responses to this questionnaire for some, I don't know, a couple hundred people or something. Right? So your task is to determine if this scale is reliable enough, and if not, what to do about it. Okay? So we're going to do this in a few steps. Like, obviously you should start by looking at the data, maybe exploring it a bit, maybe looking at the distributions of answers for each item, something like that. Get a sense of, what the responses look like. Then we're going to compute something called the item total correlations. So this is the idea that if you take any individual item on the scale, meaning any individual question on the scale, okay? So let's say G1, right? That gives you a distribution of scores on that item across all the responses. Okay. You compute the correlation between that vector and the sum of all the other scores on all the other questions, right? So for G1, the correlation between G1 and G2 through 7. For G2, you do, G2 against all but G2 and so forth. Okay? So you take the one out from the remainder, right? You add all the other ones up, take the one out, and compute the linear correlation between these two. Right? So this gives you a sense of how well each individual question moves with the scale as a whole. Right? Does it move consistently? Is it correlated with the scale as a whole? Versus, for example, it could be anti-correlated with the scale as a whole, or not correlated at all. So let's see what that means. That makes sense? The ask here? Yeah. And so one thing that could happen is if you get a negative correlation here, right? So, the higher the scores on this one question, the lower typically the scores for the other questions, or vice versa, right? If these are negatively correlated, that's probably could be an example of a reverse coded question like the ones we've had before. Which is what you'd expect, right? People strongly disagreeing with a reverse coded question when they strongly agree with the positively coded ones, and vice versa. Okay? So just compute these different correlations and let's look at them. If you detect negative correlations for reverse coded items, the practice is to reverse score them. Okay, so change the scores and change the questions consequently so that it tracks in the same direction. Right? So, the I hate writing question, you would essentially flip for the purpose of the analysis into I love writing, and you would also flip the scores. Right? So if let's say we have a 7-point scale here. Right, so that means strongly disagree is 1 and strongly agree is 7, and all the other ones are in between. That's the case, right? You would reverse score this by assigning 8 minus the actual score, for example, for each of these questions. Right? You just change the direction. Right? So if it was a 1, it becomes a 7 and vice versa. If it was a 3 or 4, it stays a 3 or 4. It was in the middle. That makes sense? Okay. And then you could compute this Cronbach's alpha measure. We talked about this a bit before. So this is, what did we explain this was? Let's see, let's go back to our thing here. Yeah, so this is some overall measure that tells you it's a measure of the all possible split half correlation. So if you randomly split your scale into 2 subsets and compute the correlations between those sets of scores, this measure, Cronbach's alpha, is the average of all of these possible correlations across all of these possible splits. Gives you a sense of how consistent the scale is overall. Okay, so you'll find a library implementation of this. You don't have to implement this from scratch. Your LLM will tell you which library to call for this. Okay? And so now we're going to look at how this alpha value changes if we remove items that had low item total correlations, if there were any. So we're basically, deciding that our scale, as we had it designed initially, was not consistent enough. So we want to remove some questions from it that seem inconsistent, right? That are not reliable. And we're going to use this approach to determine, which of those questions to remove potentially. Okay, that makes sense? So that's it, roughly. This is the activity for now. So the way I would do this is in an IDE, you could use RStudio if you're an R nerd, or you could use any coding IDE with a notebook. I like to write R for stuff like this, and I set up an R kernel in a Jupyter notebook inside VS Code. You could do whatever makes sense to you, whatever you're most used to. You could just directly do this in Python somehow. That's also fine. And I would obviously use an LLM to help you write all of these scripts or whatever, write this for you. So you don't write this from scratch unless you know how to do this yourselves. That's fine. But you don't have to like figure out how to do all of this from scratch. You can use an LLM for this. I do want you though to walk through the steps in order here so we can reflect on what's going on. Like even if you use an LLM to generate all of this, I want us to reflect on what's happening. Okay. So let me try to make this a little bit smaller here. There. Is it clear what we're doing? I'm going to keep this up on the screen here.